is out a little bit late, just got a little bit ahead of me. So some of you might have already done 6.1. It is a lot of review from Algebra 1, but in case you haven't or just want to get a little more info on it, this section, this video is going to go over 6.1, and I'll have another one up for 6.2 that we talked about today. So again, hope you guys had a good Thanksgiving, and let's go ahead and get started. So I'm going to go ahead and share hopefully this works. I'm going to go ahead and share my screen here. Actually, let me spotlight this video here, and hopefully that's working for you and that you can see what's going on. So 6.1 has to do with ratios, proportions, and the geometric mean. So the first two things, ratio and proportion, should actually be review for you. So just to remind you what a ratio is, it's comparing one thing to another. So today in class, we talked about Thanksgiving. So hopefully you all had a good Thanksgiving. And we talked about who liked pumpkin pie and who didn't. So it turns out in our class, there were 11 people there, I included myself. And out of the 11 people, 6 liked pumpkin pie. Oh, that's my home phone. 6 liked pumpkin pie out of 11 total people that were there. So a ratio of people that like pumpkin pie to total people is 6 to 11 for, this was the second class today. So second geometry class at 1 o'clock, 6 to 11 ratio of people that like pie to all the people in the class. So that's just a ratio. It's a way of comparing two numbers. We can write ratios in 3 different ways. So we can write ratios as a fraction, like I just did here. And you hear when I talked about the ratio, I said 6 to 11. So that's how we talk about a ratio. You can also write a ratio like this. You can write it as 6 and then the colon, right? 6 to 11. So that's another way that we can write the same ratio. These two are equal to each other, just 2 ways of writing the same thing. Another way that we can say this is we can actually say it with words. So we can say 6 to 11. So all 3 of those are ways that you can write a ratio. So again, when you say the first 2, you actually say 6 to 11. It's just how you actually write it. So those are ratios, lots of different ways that we can do that. Again, should kind of be some review for you from Algebra 1. So what we talked about in class then is we can actually simplify some ratios. So right here we have a ratio. We have 76 centimeters to 8 centimeters. So can we simplify that ratio? So I'm going to write that over here on the right-hand side. We've got 76 centimeters to 8 centimeters. So if I'm going to change a ratio from the form that it's in now to a fraction, the first number is the numerator and the second number goes into the denominator. The thing that I like about fractions when you're trying to simplify a ratio is that then all the fraction rules come in. So I think it's actually easier to simplify as a fraction. And you'll notice when I put it in a fraction form, you'll notice it's centimeters over centimeters. So I have the same unit. So that means that I can cancel out the units. So because I have centimeters over centimeters, those cancel out. And I try to do 76 into 80 and that doesn't work, doesn't divide nicely for me. But I know that both of these are divisible by 4. So if I divide the top by 4 and the bottom by 4, my new ratio becomes 19 over 2. Right? Because 76 divided by 4 is 19 and 8 divided by 4 is 2. And so if I simplify my ratio of 76 centimeters to 8 centimeters, another way I can write that is 19 to 2. So that's actually the same ratio. It's just written in a simplified form. That's how we simplify ratios, all right? I do want to do another one, though. I want to do number 2 down here and talk about that one. So let me make a little space here. All right, so exercise number 2, it says to, again, we're going to simplify the ratio. So we have 33 yards to 9 feet. So again, I'm going to, instead of just keeping it in a straight form, I'm going to write this as a fraction. And what do you notice about this when you write it as a fraction? Are we in the same units? Can I cancel out yards and feet? Nope, right? Can't do it. So I'm going to have to do something if I want to cancel out my units to be able to do that. And what I'm actually going to use is something called a unit multiplier. So I know from my math experience that 1 yard equals 3 feet, right? Get a yardstick out, there's 3 feet on it, that's the conversion for that. Call that a unit multiplier. So what I'm going to do is I'm going to multiply this by 3 feet divided by 1 yard, okay? So I'm going to put that here, and I'm going to multiply the 33 yards over 9 feet by 3 feet over 1 yard. I promise it's going to work out. So let's do a little math. I'm going to multiply it, and when I do that, what happens is I have a yards in the numerator and the denominator, and I have feet in the denominator and the numerator. So all my units canceled out, which is what I'm kind of going for, right? So now I just have some numbers across the top I need to multiply. So 33 times 3 is 99, right? And 9 times 1 is 9. Now, you might be tempted to just divide this out and get 11, but we remember we're working with ratios, so we want to keep it as a fraction. So 99 over 9 is the same as 11 over 1. So another way of writing the ratio of 33 yards to 9 feet is 11 to 1. Okay, so if I wanted to simplify this ratio, it would be 11 to 1. There we go. So that's the answer. Now, this is what I was getting all excited about in class today. If you talk to anybody from class, you can ask them about it. I was a little excited about this. So I always like to point out why we can multiply by something like this. So what I mean by that is, remember in all of Algebra 1, he was like drilled into your head, like if you're going to do something to one side of the equation, you have to do it to the other side of the equation. You can't just like multiply something out of thin air. Like if you have, 3x equals 9, you can't just multiply one side by 3, but not the other side. You have to always be balanced. And so what confuses a lot of people is why can we, and this problem I just said, we're basically going to multiply something out of thin air. Kind of felt like that, right? I said, we're going to multiply this by 3 feet over 1 yard, and that'll help cancel out our units. It's like, well, wait a second. You can't just all of a sudden multiply something by 2 when it's the same thing. We're not allowed to do that. The thing that what I just kind of crossed off in green here and I'm highlighting in red and it's becoming very Christmassy. The thing that's really cool about these is we call these unit multipliers because if you think about it, we just said up here that 1 yard equals 3 feet, right? So they're like the same thing. 1 yard is 3 feet. 3 feet is 1 yard. Like they're the same. You could write this as 3 feet divided by 3 feet, right? So really, this unit multiplier is just like multiplying your original ratio by the number 1. Because 3 feet over 1 yard is like the number 1. It's not changing anything. It's not converting it. It is what it is. It's 1, right? And we do have a property, the identity property in multiplication, that lets us multiply any number by 1 and get the same number. So really what you're doing here when you use a unit multiplier, and it could be, right in this one, it's yards to feet, you're just multiplying by 1 to help you convert better. And we use these unit multipliers all the time. The reason I like to point this out is because if you're taking conceptual physics, I know for sure you'll be using unit multipliers. If you do chemistry, you use unit multipliers. If you do regular physics, you'll be using unit multipliers. Like we use this a lot in not just math classes, but other classes to help us simplify units. So 3 feet to 1 yard is an example of a unit multiplier, one that we use a whole lot. I know when you're talking about time, is, say you have something that's 3 hours long and you want to know how many minutes it is, we can just multiply 3 hours out of nowhere. We can multiply that by 1 hour is 60 minutes, right? 1 hour is 60 minutes is a unit multiplier. It's just like multiplying by 1 because 1 hour is 60 minutes. Like they're the same thing. So that's why we're just randomly allowed to multiply with 3 hours by 1. It's still 3 hours, right? But this idea of multiplying by a unit multiplier basically allows us to convert things so that we can say, oh, well, 3 hours is 180 minutes. Okay, they're the same thing. So I know that that's probably something that you guys know, but just in case, it'll be helpful for any of your other classes. Okay? All right, one other thing with ratios that I want to talk about is actually in example number 3 right here. So example 3 says, the measures of the angles in triangle BCD are an extended ratio of 2 to 3 to 4. An extended ratio of 2 to 3 to 4. So an extended ratio just basically means that that's the most simplified ratio, right? So this triangle has a ratio of 2 to 3 to 4. Now, does it actually have angles that are angle 1 is, 2 degrees and 3 degrees and 4 degrees? No way. That would never work as a triangle. It'd be like super smush triangle. Crazy, right? But it's a multiple of that. And so the way that we would solve something like this, you've seen they've drawn a little drawing here for you on my example number 3. They've drawn a little drawing is that we know that the angles are some multiple of that, right? So the way I talked about this in class is we know the ratio is 2 to 3 to 4. Another way you could write 2 to 3 to 4 would be multiply everything by 10, right? 20 to 30 to 40. All right, but 20 to 30 to 40 doesn't still quite work for a triangle. So, I can multiply by 15 and I would get 30 to 45 to 60. Doesn't quite work as a triangle. So instead of playing this guessing game of what to multiply by, I'm going to say, what if I just multiply everything by x? Okay, so that means my angles are 2 times some multiplier to 3 times some multiplier to 4 times some multiplier. That's going to be my ratio. So it's the idea of introducing x because that basically just tells you what to multiply by. And that's what this picture shows up here, actually. So how this helps is I have one other piece of information, and that's that I know that all triangles always add up to 180 degrees, right? So if I add up my angles, I get that angle 2x plus angle 3x plus angle 4x has to equal 180 degrees. Okay, then I simplify that and I get 9x equals 180 and x equals 20. So I'm not quite done. I figured out what my multiplier is. My multiplier is 20. So that means that my angles, right, are going to be multiplied by 20. So the actual angles are going to be 40 degrees, 60 degrees, and 80 degrees. And those will give me angles that add up to 180 and are in the ratio of 2 to 3 to 4. Okay, so that's how you do extended ratios. All right, so now we're going to leave ratios behind and we're going to move on to proportions. Okay, so a proportion, sorry, scrolling, I can do it, not that far. I need a new mouse, guys. Mine is misbehaving. There we go. All right, so a proportion, just before we get into all the words on here, I'm going to go off to I'll do it right in here because I can always delete it. A proportion just basically means two ratios that equal each other. So we talked about in class if, in our class, like I said, 6 out of 11 people liked pumpkin pie. That was our ratio, right? But what if I extended that ratio out to all of core B, C, and D, okay? And I found out that in core C, B, and D, I just said that weird, there's 110 students, okay? And they like pumpkin pie in the same ratio. So if in our class it's 6 to 11, but there's 110 students overall, that means that 60 of them would like pumpkin pie. So this is just another way of writing the same ratio, but all of a sudden when we put two ratios equal to each other, then they become a proportion. Dun, da, 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 right? And so we learned different ways probably growing up how to solve proportions. You probably noticed I did a really easy one and I multiplied the bottom by 10, which means I need to multiply the top by 10. And that's how I was able to tell that that proportion is true. Right? But we do have a little bit more sophisticated math than that. Now, I don't know how much more sophisticated it is, but maybe. There we go. We do know that if we have any proportion, that we can actually use something called cross products, the cross products property, to solve a proportion. So a proportion is when you have two ratios that are equal to two fractions that are equal. And in a proportion, the means of the extremes equals the product of the means. So I'll talk to you about what that means. But we call this the cross products property. Some people I know call it the butterfly. Basically, if you multiply B times C, sorry, we have two ratios, A to B equals C to D. So if we multiply B times C, that should equal A times D every time if our ratio is true. Okay, so a little example here. If you've got 3 times 4, that equals 12. And if you've got, sorry, that's a 2 under there, 2 times 6, that equals 12. And so this is a true proportion. It worked out for us. So that's the cross products. Some problems, like I said, sometimes it's not even worth doing the cross products for, but sometimes we might need that. So for example, in 3/4 equals x over 16, if you want to solve for x there, this might be a case where you just notice, oh, well, to go from 4 to 16, I multiply by 4, so I have to multiply the top by 4, so therefore x would have to be 12, right? So you could do that to solve for the proportion. But and you could do cross products too. We could do another way. We could do 4 times x, right, equals 3 times 16, and then divide both sides by 4, and we get x equals 12 that way. So that will work. All right, try B on your own. I'm not going to make like a long pause here, but try B on your own. You can pause me. And what you should end up getting is x equals 2. So if you didn't, I want to make sure you remember one thing. So we're going to cross multiply to solve this proportion. So we get 3 times x. And then this is the part that tricks most people up. When I cross multiply this way, I get 2 times x plus 1. X plus 1 has to be in parentheses because you're multiplying the whole quantity. So you have to make sure it's in parentheses and you use the distributive property. So 3x equals 2x plus 2, which means that x equals 2. So again, make sure that you use that distributive property. Okay. All right. So far, so much fun, right? One more thing I do want to tell you about though. So back to our proportions, and I kind of read through some words there pretty quickly, but I want to tell you that that's the letter A. AB over CD, right? This is our proportion. So the letters in our proportion actually have special names. So this and this letter, the C and the B, in those two spots, we actually call those the means of the proportion, the means. So you can see it up here, the product of the means, okay? And then the A and the D, we call those guys the extremes. Okay, now a lot of times when you're solving a proportion, you don't say, I'm going to multiply the extremes by the means, right? You just know you're going to use cross property and cross products and no big deal, all that stuff. But where it becomes important is when we talk about doing something called finding the geometric mean. So you see that box here, the geometric mean. So I just told you that these two green, now blue things are called the means, right? So the geometric mean is actually going to take advantage of that. And instead of having two different numbers, a B and a C there, what we're going to do is we're going to try to find a number that's true for both the denominator and the numerator in each of our proportions. So I just turned those into an X. I know it's super messy. So if you'll allow me, we're going to scooch over here, and we've got A over X equals X over B. Okay, so these two x's, remember, are your means, and we're talking about finding the geometric mean. So these x's represent your geometric mean, okay? And A and B represent your extremes. They're still your extremes, right? Extremes and your means. So to find the geometric mean, you're going to use this idea of a proportion to solve. Okay, so if this is very generic up here at the top, if I wanted to cross multiply, it's going to be x times x, right, which is x squared, equals a times b. And another way to say that is that x equals the square root of ab. Right, so let's actually do a real problem with this. So find the geometric mean of 16 and 48. So what we're going to do is 16 and 48, nope, not there. Go back. There we go. 16 and 48 are going to be your extremes. And x are going to be your geometric mean. So this is how you set up something to find the geometric mean. And so what you're going to do is you're going to multiply. So we're going to cross multiply, right? We've got x times x, so we've got x squared. And then we've got 16 times 48, which is, ooh, I don't have that handy. Give me a second. Let me calculate. Give me a second. Dun, dun, dun. 768. I remember what the answer is, but I don't remember how to do it. All right, 768. So in order to solve this, you have x squared equals 768. What you're going to do is take the square root of both sides, right? Because that will undo the square. So x would, if you do that, is going to equal approximately 27.7. All right, so that's how we would find the geometric mean, is to do that. Now, one last little thing. Sometimes we need to find the perfect square. Like we don't want it in decimal form, sorry. And so sometimes you might, instead of just evaluating 768, you need to think what perfect squares we can divide out of this. Okay, so actually I happen to know that 16 squared, sorry, I'm calculating here, 16 squared is 256. So another way to write this is 256 times 3. Okay, so 768 is the same as 256 times 3. So why is that important? Well, that's important because if you want to keep it in a square root form, we can write this as 256 times the square root of 3. All right, and I happen to know that the square root of 256 is 16. So 16 square root of 3. So in some cases, when you find geometric mean, you would see a decimal, right? Here's my decimal, 27.7. And in some cases, you'll see a number that is in exact form that we've basically just simplified the square root, the radical. So that's that form right there. So that's all for 6.1, and I'll reach out if you guys have any questions. Thanks, guys. Oops. Bye.